Hello colleagues, glad to see anyone today in our event. And let me introduce myself. I'm Igor Bardowski, Sales and Support Engineer of Woodwork for Inventor team, and we will begin our presentation about Woodwork for Inventor version 9. So we will begin our demonstration from the concept about how Woodwork for Inventor works. As some of you probably already know, Woodwork for Inventor is not a standalone application. It utilizes Autodesk Inventor as a 3D CAD engine. So this powerful tool allows you to design anything of any complexity and shape, but it does not suit for woodworking. That's why we developed our tool, which allows you to assign woodworking attributes, make calculations in order to prepare data for manufacturing. So they are working in tight connection. Woodwork for Inventor works together with Inventor 2019, 18 and 17 versions. So you may wonder, why do we choose Autodesk Inventor? In modern war, today's design complexity rises significantly. Nobody wants to buy some gray boxes. Everyone wants to get something unique. And using Inventor, you can design something such complex as this thing that you see on the screen. So that's why, if you can do this, probably you can build very complex and nice looking furniture. So now let's speak about the general workflow. We start our design from a skeleton, which is basically a very simplified concept of our model. Here we can check our assumptions, if this design works for you, and so on. If it turns out that it works, we can fill this skeleton with iBoxes, which is basically predefined items such as drawers, doors, etc. At the next steps, we assign materials, set the grain direction, and oversizes. When it's done, we move to the hardware in order to join components together. So at this step, we finish the manual work and all the magic stars. From the model, we get a bill of material automatically. As well, we generate the drawings, CNC programs, and finally, the nesting. So now let's see how the design process looks like. As I mentioned earlier, we utilize skeleton design approach, which basically means we start from a general shape, then we convert it to the skeleton to apply the panels. Then we can copy them or clone them, trim them, miter them, in order to get our design done. So this allows you to have the model built very rapidly. It is parametrically driven. You have all the controls in one single file, and you can check many what-if scenarios. You can build maybe 10 models in order to check which of those will work best for your case. Now let's see how does it happens in Woodwork. So as I mentioned earlier, we start from a generalized shape, which is parametrically driven. For this illustration, we utilize the box, but the shape of your skeleton can be very complicated. So as you see, we define the size of this box using the parameters. We change the name. Now we are going for the dress-up function of Woodwork for Inventor, but before using it, we will add some more parameters. One of those will drive a panel thickness, which in this case would be a multi-layer panels. Other panels will be standard 80 mils panel. Also, we would like to control the quantity of the drawers. Maybe we want to have 3 drawers, maybe more. We will change them in the future, change those values in the future. Also, we define the shelf quantity, an offset from the left and from the right for the separators. Maybe in this case, those would be symmetric, so we can utilize the same parameter for left and right, and we are ready to go. Let's use the dress-up function, choose all the faces, but not the front. And we can set the parameter that we defined earlier, which would be a body panel. Okay, now we are setting the parameter for the backplate, say what we want to see, what's not, and we're using a copying of our panel. So we clone the panel using offset for the spacer and define the thickness. The same from the other side. Okay, now it's time to do some trim operation because the panels intersects. So we're saying that those panels must be trimmed by surrounding. The same from the back. Now about the corner, we need to use miter here. That's it. We get cut by half of an angle in just a few clicks. Okay, so you can mix the workflow with Woodwork for Inventor using standard Autodesk Inventor tools. For instance, you can just directly define an offset from the edge using Inventor Direct tool. Okay, now it's time to draw the doors, which would be on the front. We can just project some geometry, use it as a reference. It's enough to just draw one single unique item. For instance, if we have the same door on the left, we can just do a mirror to get it on the right. Okay, let's use a panel parameter to drive the thickness of the door. Okay, now let's project another separator, and we want to know how much space do we have here. So we'll make a driven parameter, niche height, and we will use it to define how much space for the drawers do we have. Okay, let's draw a facade of one of them. Sets its size, which would be the size of a niche divided by amount of drawers. Very simple math. Okay, that's it. Let's make an extrusion. And basically, after a while, that's what we have. As you can see, this model is made very rapidly. It does not take a lot of time for you to design it. However, it allows you to check your assumption if this model will work in 3D. You don't need to design something with a pencil and a paper. You can just do this in a 3D, and it's parametrically driven. You can just control it by changing the parameters in order to find the best solution for you. So, what data do we have so far? We have a furniture concept, which is parametrically driven. We define the panels, and as well we define the place for iBoxes, which would be a drawer in this case. Now let's see what can be done with those drawers. Because drawers is more or less the same, only a few parameter changes, the width and the depth, so we can define them in advance. And such a components is called iBoxes in our terminology. So now that's how our model looks like. Now we need to went to the assembly environment in order to work with the components. Let's make some of them isolated from the other. Now it's time to use iBox in order to insert the drawer. Now in the background, the copying process happens and we get a fresh copy of the drawer. And it's enough to just pick some reference geometry, the top, the front, and the side in order to place it correctly. Of course, those models can be more advanced. For instance, they can have some iLogic rules inside, which allows you to choose a hardware configuration and so on. In this case, I will illustrate this by just picking a door component. Again, let's pick the top, the front, and the side in order to place it in the correct location. But as you can see, the hinges is not placed correctly, so we can open the component, go to the iLogic rules, door configuration, and here I'm just saying that I want to change the hinge position. Okay, that's it, we have door in place. Now what we should do, we need to multiply the components in our assembly, because as you remember, we have just one single item for a design, one single shelf, one single drawer, and one single door. Now we need to multiply them using arrays and as well as a mirror function. Okay, we can just say we want to mirror the shelves as well as the door from left to right. And as you can see, we can just copy components or we can reuse them. Okay. The same will happen with the frame, which basically holds the top piece of glass. Okay, we are saying that we want to at first combine those frame components in one single assembly. And once it's done, we can fix the position using grounded tool. Then we can do a mirror in order to mirror the frame from the front to the back side. Because we are lucky, our model is symmetric, so we can easily do this without any effort. So as you can see at this step, it does not take a lot of time. We already have iBoxes on the places, and we duplicated similar instances of an object. So we changed the amount of shelves, drawers, as well as we duplicated the frame from the front to the back. Once our initial design is complete, we can go for the materials. We have our main material types as well as the colors. So first of all, let's start from the main materials. As you can see, they are measured in different measure units. They might be profiles or solid wood components, as well as different kind of boards. So when you just draw something, it's not clear how to measure it. Is it a volume or is it a length? Maybe you want to measure an area. And once you assign a material type, Woodwork automatically knows which measurement algorithm should be applied to this item. Beside those standard panels, we have something more advanced, like a multi-layer boards, for instance, which is basically made from top and the bottom covers and some layers in between. And what is interesting about that you don't need to design such thing in Inventor. It's not an assembly. In Inventor, it's just one single thick board. Okay. The next thing is composite structure, which can basically made of any different panels or profiles or combination of those. And as a result, what you have here is different materials which is measured in different algorithms. They may have different oversizes, grain directions, and etc. And what we get as the result is like a complete BOM structure for this item. We will dig into details of each of those layers before they are glued. Okay, so I mentioned that we have some covers, and let's see what of those covers do we have. There is edgebanding, paints or lacquers, and veneers. So now let's speak about material groups at first. When you start your design, for you it's not very important what is the color of your material. Is it white or is it black? It does not change the shape of the part. Okay, that's why we can start to work with materials by just grouping them by the physical role of the part in the model. Let's say those parts is like for a corpus, those are made for the facades, and the same idea goes for the edgebanding. Okay, we don't know actually what the coloration would be and so on. For us, it's important to set right position and right thicknesses of those cover materials. Once it's done, later during the design process, we will do some adjustments, and finally, when we go to the BOM, we can do such a called mapping operation, which basically connects the data from your design stage with real codes and names of those materials. What it allows you to do, it allows you to have one single model with many different BOM variations. So if you take a look at how the part is presented in Inventor, you can see that this is like one single item. But for the Woodwork for Inventor, it's something more than that. As you can see, it contains such a data like field workpiece items, as well as the oversizes of all of those. So we can have like each part exploited into the subcomponents. In terms of the design, of course, you don't need to design each part as an assembly. It's enough to just set right materials for it. So let's see how does it happen. We have like a raw model. Some of the panels already have material because it gets from the iBoxes, and what we're doing here, we're assigning a multi-layer board which is predefined in advance. So in advance we said that this is like 4 layers, 2 veneers and 2 MDFs in between, and that's basically it. You don't need to split each part in 4 layers. Now we are going to assign rows or profiles, and those are going here. Because those frames are basically the same on left and right, it's enough to set it for only one. Okay, so now it's time to do some tweak. We can hide the components. And now, once it's done, you see that there is some part which is still have no material assigned. So let's pick a laminated board and say you want to apply this for the rest of the model. And what it does, it applies the material selected to the parts which had no material yet. Once it's done, we can go for the edgebanding. Again, because we have the same item, a shelf on the left and right in a row, it's enough to just pick one single item and then it goes all the way between the identical elements. Okay, so now why do we choose such a long process? Under modeling, we can stay with such an assumption that we are working with some material F1 and B1, which stays for facade and body panels. Then the question is how to work with real codes and names, and we have an answer for it. We use material replacement. And next question is where to get the material codes and names from. And we can get those from ERP system, which basically is your place for keeping this data about the materials. So we can get the material from ERP, utilize those materials in the material replacement in order to get real codes and names used in your factory. Okay, the next step, we get a bill of materials, which is basically utilize the same codes and names as your ERP system. And because those are, let's say, relatives, yeah, we can just send the data back to the system. The same codes and names will be also used in the drawings as well as in the CNC programs. Moreover, all this data can be sent to the PDM system, which in this case would be an Autodesk Vault. But we will speak about the Vault a few words a bit later. So now, what do we have so far? We have set materials, the woodworker materials, which have the main core material, some covers. We set the grain direction, and we also can set an oversize for the materials. Okay, so now the next question would be what to do with the hardware, because those panels are not connected together. So what should we do? Okay, so in order to join the items together, we need to apply some hardware. And this hardware is shipped with Woodwork for Inventor library. Each hardware item is a parametrically driven object, which is controlled by an Excel. So if you change some Excel values, you will get new rows of the parameters, you will get new items in your library. This library is unified. What does it mean? On the left, you can see various types of door handles. They are different by their shape, color, and manufacturer. But they have something in common. They have the length. And so if we will drill a hole in the facade of your model, we can basically take any of those and apply it to the model. That's why we can replace all those different handles with one single model of Woodwork for Inventor, but we need to know exact code and the name of the component should be used. So again, the replacement tool can be used for this purpose. Okay, so let's see how this happens in the model. First of all, let's make some components invisible. Okay, and now we need to add some additional features like work planes in order to set a position of our hardware items. In this case, we set a few additional work planes for the side panel. Now we want to isolate the shelves because we also want to have some mid planes here. Okay, we have the mid planes for the shelves. Now we can undo isolate to go back to initial situation. And now we are using Woodwork Attach tool, which allows you to select the hardware components. Each of those may have different configuration, different length, and so on. And now, in order to place the component, we need to just basically say where is the nested board, where is the pillar board, and where is the axis. Okay, that's basically it. So we have our minifixes placed. So now we need to repeat this step for the other set of the components. Pick another axis, another nested board, another pillar board, and we will get the back plate connected. That's it. Now we can close this dialog And again, let's use a visibility control, but in this case, we want to see only the hardware items. Okay, we can look for the files in the browser, because some of those components need to be changed. We will swap the dowel position from left to right side. And now the iMatch tool will be used in order to match the configuration of selected object with the selected template. As you can see, in just a few clicks, we can easily configure our furniture model. So we can repeat this step for the other hardware components. For instance, we want to get rid of this dowel at all for the mid components. Okay. And that's basically it. So we have the set of minifixes. Now it's time to place some more hardware. Let's navigate through the library. In this case, we will place shelf support. Let's pick the sides and the separators and the bottom of the shelves. The last one will be the axis. And that's it. Our shelves are now positioned on those supports. Now we want to connect some side panels with the top and the bottom components. In this case, the angle between this minifix connector can be various. Yeah, so we can say they want to just place some more advanced item, which is driven by iLogic rules. Now we can say that we want to place it here. There is the first inner plate, there is the second, and there is the axis. And now this component set its angle. We'll just duplicate it all around, on the top as well as on the sides. Okay, so once it's done, we will delete the first one, which was placed to the for the reference, and that's basically it with the minifixes. So now we can make those components visible again. And lastly, we will place some conformants. Let's choose the thickness of connected items. Okay. Now the nested boards will be the side panels, or the sides of our frame, the pillar board, and again the axis. Okay, now we can attach it. So once it's done, once all the hardware is on the place, we can use Sculpt in order to generate the holes for the hardware. And as you can see, it's not just some marking, but it's just physically removed material from the model, which allows you to do CNC operations and so on. So this step, that's how our model looks like. Let's go for the wood joints. This is like another sort of hardware, which is not hardware actually, but it's like a way of joining the items together. So those can be of any custom shape, size and material, and they allows you to remove the material from one side and add it to the other. Just a second, please. Okay, so what we have so far is the hardware, which is automatically placed. It's easy to configure, and moreover, it generates holes in necessary components, so you will never miss the connection between two or more items. So now let's go for the next question about the BOM, where the number matters. So those numbers usually are calculated by like in a separate step, or maybe even by another person, and this is like the place when we get a human mistakes. our case bill of material is model-based. It allows you to see cut panels, edge banding, dimension, and quantities of all the materials, as well as purchased hardware items. Moreover, you will also see another information, which is basically not the model prerogative, but this is like a manufacturing request prerogative. So this is like one of the examples how the BOM report can look like. How it will actually look depends on the template that you're using. So what is the template? We will speak in a moment. Okay, now let's see how does it works. When we have our finished model, we are going for the tool which is called material replacement. And what it does, it allows you to create new material configuration scheme. Okay. We can say that we want to see dark facades and light bodies, for instance. Okay, now we need to set up where to get the data from. And here we are going for materials, which is basically kept in XLS file. Those XLSs, of course, can be different. So now we are doing the mapping. We're saying which of those columns in Excel contains the name, code, and the appearance. Okay. And now we're saying that our facades or body panels is made from this material, internal parts is made from the other. And it's very easy to set up different coloration schemes by just picking a new material from this list. Once it's done, we can apply appearance replacement. And what will happen, the model will look like if it is made from those materials. Okay. Again, it's not very important for designers to see those. It's more important to have codes and names set up correctly. So now we can do similar thing with the hardware. And finally, we are choosing a template, which basically differentiates how the report should look like. Those reports are model-based, which means that you have all the items calculated by the model. Okay, what we have so far, it's like a product structure which basically lists all the items in your assembly. Now we have a part list which calculates how many identical parts we have all across the assembly. Cutting part list indicates where is the parts need to be cut out from the workpieces. Material summary, which calculates how much raw materials you need to request from your supplier. And basically, the strong point here is that all this information is model-based. You don't need to waste your time on doing some manual things. If we'll choose another template, which in this case will be a price calculation, we can just get a rough estimation about how this model can cost. And we can just multiply the amount of material by a prime cost per unit. And what we will get in the result in the material summary is like primarily price estimation. Okay. So as you can see, it happens very rapidly. If you don't like the prices and so on, you can just change the size of your model and you will get new price lists. Okay. So now, so far we have template-driven BOM. It is model-based. We account the size of the workpiece, depending on the grain direction and oversizes. And also we work with multi-layer boards with different colors and so on. Now it's time to move for the drawings. Okay. What do we have here? Those drawings are automatically generated, which means again that you don't need to waste the time on placing an items on the drawing. They again are template driven. What information we have on the drawing includes grain direction, dimensioning, and the drilling table. If you did your CNC, you will get the base point of a CNC on the drawing. And drawing positioning is basically the same as you get in your BOM. So as you can see, those numbers are basically the same. It's very easy to navigate in the drawings. Moreover, in some cases, it's also important to know to which assembly this part belongs to. Okay, so in this case, we see a parent information, a parent name. Let's see how does it happens in Inventor. In Woodwork for Inventor, of course, sorry. So what we're doing here, we're defining how the autoplot works. Yeah, so we are defining the template behavior, how much space we have for the drawing output, how the views should be aligned, what projections we want to see, what is the colorations and thickness of the lines. Okay, do we want to see a whole table or not, how those whole tables should be generated. Maybe we have some predefined names for a different kind of holes, etc. So we can utilize those. Yeah, and finally, what symbols will be used for the marking. And maybe we want to generate PDF, DXF, or the WFs simultaneously with the main drawing output. So what we can do now, when the template is set up, basically we need to just start the drawing generation process. Okay, so now this assembly have more than 200 parts. You can imagine how long it will take to just place the views on the drawings, but it's done in just a few minutes. So we have all the panels arranged on the assemblies. We have a grain direction, which indicates how the grain goes. If the part have edgebanding, it also illustrated. Moreover, we have the coordinates for the drilling in a hole table. If the part contains some holes, you can see hole coordinates. Also, you see the size of your final part as well as the workpiece for this part. If you have multiple assemblies, then the main assembly will be shown, and it will be followed by parts which is included in this assembly item. So far we have drawings, which is template driven, model based. We have hole marking, which can be easily adjusted, grain direction, edge banding, legend, part and workpiece sizes. And now it's time to move for the CNC. Okay, so here I can say that some of the companies get rid of the drawings for the parts. They just define the virtual CNC machine in Woodwork, and it allows you to just get the CNC programs directly from the parts. They just have drawings for the assemblies. Now, what should be done in order to get those CNC programs? So first of all, you need to define what tools are placed in your machine and how those tools can be oriented in the spindles. Yeah? Once it's done, it combines the machine. Yeah? So you can just make a digital snapshot of your real CNC machine in Woodwork. And then you need to teach your machine how to behave in case if you need to, let's say, do a milling or cutting operation. What is the priorities when you place something on the machine? How to behave if you place a workpiece with oversizes? What is the operation priority? What is the ratio for an operations, and so on. So normally this should be done only once, and once it's done, you can generate a CNC programs from the model. And how does it happen? So first of all, Woodwork recognizes all the technologies like drilling, milling, cutting, etc. from the model, which is very nice because you are not limited by the way how you do design. You can use one or the other design workflow. And finally, once it's done, Woodwork technologies run through the post-processor directly to your machine. There is some post-processors which is available for different machines. As you can see, there's many of familiar brands, but don't worry if you don't see your model here in this list, because custom post-processors can be made on demand. Okay, and now let's see how does it happens in a model. Just for an illustration, we will isolate one of those parts in order to assign some oversize for it. Okay. We are saying how this oversize will be placed. Okay, let's say we'll have just few mills all across the model, and we are just going to the CAM environment. Okay, this part contains some holes on one of the sides. Now we're choosing what equipment will be used for processing. When the machine has been set, we are saying what is the condition. Is it a part with oversizes, or is it just a workpiece? Is it a workpiece with oversize or just a workpiece without them? Once it's done, we can do a technological operations, which in this case would be a drilling. Okay, so now this model already have a technology, but a lot of those models still doesn't. A lot of those parts still doesn't have any CAM technology. Now let's go back to the assembly environment. There is the tool which indicates if the part have a CNC status or not. In this case, only one part had CNC technology, but we will fix it very easily. Let's apply auto technology for all the assembly. And once it's done, we can just say, okay, I want to use this location in order to place the files that I've just generated. Okay, that's it. And as a result, we will get a lot of CNC files. In this case, because those were generated for Woodwork, we will get MPRs. If you open those, you'll see that besides the shape of the part and all the technologies, we have the base point indicator, the grain direction indicator, and as well we have edge banding. So as you can see, there is no place for a mistake. Since the operator can easily understand how this part is oriented, where is the edge banding, how to place it on the machine, basically there is no room for mistake. So what do we have so far for this step? We have rules-driven recognition algorithm, which understands what is the rules on the factory, how to process the parts. Technology recognition happens on the model of your parts. It's geometry based. You don't need to design any rules in advance. Just model what you want to make, and Woodwork cares about the rest. Different parts processors allows you to apply the technologies on different machines, and those technologies are ready to use. You don't need to do additional programming. Now let's speak a bit about the nesting. How to optimize how much material we waste on our models. Again, let's go back to the CAM environment, but in this case we will ask a system to make technologies for the nesting machine, which basically does the contour shaping from the top. What happens, system analyzes the geometry of the part according to the rules defined, and basically that's it. All different materials are placed in different workpieces. Okay, and if you like, you can just play a Tetris here. You can just take the parts, rotate them, place them in the other location, stack them together in order to optimize the waste of the material. Perfect. Now we can crop the sheet. That's it. And finally, we can generate an output in different formats, which can be DXF, which is commonly used for different nesting machines. Again, just enough to say where we want to save the files. Okay, and that's basically it. Okay. There is a lot of DXFs. Okay, so what do we have so far in terms of the nesting? It's automated in terms of how it is made. Different materials are placed on different workpieces. If you want, you can override the layout. Maybe you see how it is better to place the part on the workpieces. And of course, you can generate DXFs beside different other formats. Now let's speak about something else, about the parameters, because at the very beginning we start our design using parameters. This means that we must have some easy way of changing the model. In fact, we have those tools. Okay, because model is skeleton built, we can just say, okay, I want to change some parameters in the skeleton level. Maybe I want to change the width, shrink the model a bit, but add some height. Yeah, so let's make our model a bit taller. Again, maybe I want to change the drawer quantity. I want to have 4 because the model is higher. And that change amount of shells. Okay. Now we need to just update the changes on assembly level, and that's basically it. We have a new model in just few clicks. Okay, so now it's up to you what you want to do. Next, maybe you want to change some set of items. Maybe you want to remove, let's say, one of the doors in order to just have another configuration. Okay, so what do we have so far for this moment? Basically, we went through all the design stages, and we start from the scratch. Of course, you understand that if you start this model from some predefined item, it will take way less time than I waste on this design. And finally, we went through all the stages. We set the materials, we added the hardware, generated the holes, made the specification by setting the real materials and codes. Then we went through the drawing generation for CNC program generation and the nesting. And finally, if you found that something is wrong, maybe I don't like the size of the final model, I can just go back to the very initial step and set the new parameters in order to see what will happen then. Okay, now let's speak about the collaborative working environment, about the Autodesk Vault. Okay, for those of you who are not familiar with that, I will explain what the Vault basically is. In just a few words, it's like a data management software which is integrated with Autodesk products such as Autodesk Inventor, AutoCAD, Revit, Civil 3D, and other products. And it allows you to work with the collaborative environment, which means that you can share work with the colleagues. You can find the work which you made like half a year ago. Maybe you found that your design which was made today is not so perfect than the yesterday's version. You can just go back in a few clicks. Moreover, you can manage non-CAD documents such as Microsoft Word documents, Excel files, PDFs, and so on. So it's just a set of all engineering data in one single place. Now let's see how we can manage this thing with Woodwork for Inventor. So the main question is how to manage all those nuances like the set of the edge bandings, hardware items, what is the size of the workpiece, what is the size of the final part, and so on. Those are not items which is controlled by Inventor, because as you remember, for Inventor a part is like one single item. For a Woodwork for Inventor, each part is like a small assembly. So that's why we have developed our own tool which allows you to generate an item in Vault Professional. Basically, we are representing the structure of each of those sub-objects in Vault. So how does it happen? Let's see. We have a BOM generator, which allows you to say that we want to set up the mapping. Yeah, so we want to have a set of parameters gathered from the model, and we basically want to transfer those to the Vault. Okay, on the Vault Professional, we have the tool which is called Item Master, which allows you to create items, which can be like a workpiece, edge banding, and so on. So here we can apply some filters in order to have more clear view. We just grouped by the type. There is the fill workpieces, purchase part, cover workpieces, and assemblies. And for each of those, we can have additional information. Yeah, for instance, for assembly, we can have a drawing. For the part, we can have ampere file and a drawing as well. So all the items in one single place. Okay, we can get the quantities of the material. We can get information when this part, where this part was used in the past. Okay, and it's again highly configurable. Maybe you want to get some additional information, like maybe a color of the material, the length, the width, and the thickness of the part, and so on. As you can see, it's very easy to do this. Yeah, each of those items like workpiece or part can have a lot of additional information. Okay, now it's time to say where is the difference between the 8th version and the 9th version. We have a separate set of slides to explain that. For those who previously utilized our 8th version, probably it's time to wake up and see what we have here. So first of all, let's see what we did on the programming level. Of course, here it's hard to say how much hours and these debates we had during the design of the night version, during the programming of the night version, developing the algorithms which serves your needs. And that's what we will discuss here, just let's say top results what we get here. So first of all, we change the database format from SQL to JSON. What this allows you to do, basically it speed up the work with the data in the database. So instead of having multiple files, now you have one single JSON file, which is basically some sort of text file, which is very easy to manage. And because we don't require an SQL, which stays in the middle between the Woodwork and the database, the direct database control allows you to work with the data faster. Okay, so when we migrate from the previous version to the night version of Woodwork, we utilize data migrator tool, which allows you to specify where is the setting file, router, and as well as the material database file, and it merges those in one single item. That's the number one of the changes, of the significant changes. Okay, now the next one is side pocket algorithm improvement. What we have here is like the trajectory of the tool, how does it goes when we do a pocketing. And as you can see on the left hand corner, we have some red square, which indicates that here we have something wrong. Okay, that's it. And now we have a new function which is called like a step down. In case if you have open pocketing, we can just step a bit down the contour of the part in order to treat it correctly. Okay, and this is like a separate parameter in the definition of the tool. Now the edge banding legend and internal edge bandings. So we have a new controls which allows you to get information about the edge bandings which is placed internally, as well as about the edge banding which is not touching the range box. Yeah, so we can, in other words, we can proceed the parts which is not only rectangular in shape, but with different shapes, as you can see on the left. Yeah, and we can say which edge banding is tangentially connected to the top, to the left, to the right, and so on. So you will see all this information in the BOM. Okay. So because we have a lot of new items, we have a new tool which is called like a keyword constructor, which allows you to see a new keywords and utilize those new keywords in order to change the bill of material or maybe drawing template in order to see more information. Yeah, for instance, we can say about edge banding, we can say where's the edge banding on more complex shape. Yeah, on the part of the more complex shape. Sorry. Okay, so as you can see, it's a very snappy tool which saves you a lot of time. So we get a new keywords. Besides all of those, we have such a keyword which allows you to indicate if this part needs further processing. If it is only rectangular shape, it basically means that after cutting, this part can go directly to the edge banding. Yeah. Also, we have a keyword which allows you to get a whole amount. Yeah? So you can estimate if the drilling is needed and how much it will take. So now let's see how this happens in a system. So let's imagine that we have such part of the complex shape. We can assign different kind of the edge bandings, different thicknesses, and so on. Okay, the shape of the part is a bit unusual. So now the grain direction shows you to the right edge. So here we have the right edge where the grain indicator points. It's nearest edge now, and we can say what is the prefixes for a different type of the edge banding. Is coincident, tangentially connected, and maybe it's point connected, maybe it's indirect. Yeah. For instance, we have internal edge banding, that's why we can use this indirect. Now let's see how we can fix our template in order to see this information. Yeah, let's just duplicate the information, and here we will have a new item, which would be a front. front edgebanding legend. Let's utilize keyword constructor. And now we're saying that we want to see an item, cover workpiece, front, legend, which means that we will get the information about the cover material, which in this case is an edgebanding. We can basically duplicate this for all the sides, left, right, front, and back, and see how now the template will look like. Okay, as you can see now, we have a lot of more information about the edgebanding. We have the codes, names, and as well as if it is indirectly connected, if it is tangentially connected, coincident, and so on and so forth. For those of you who are working with part of the complex shape, is very useful. Okay, the next thing you already saw during the demo, but I didn't focus your attention on, is that since the night version we have the coloration on the model changing according to the materials you used in the material replacement. Yeah, so if you change the materials, color changes too. Let's see how does it happens. There's a new material replacement tool which allows you to see the materials on the object. You can group those by the colors or by the main materials. And here we can just say what is the material replacement scheme. Yeah. Creative names always works. Okay, now we need to just do the mapping. We need to say where to get the data from. Again, we can easily connect an Excel document. If you use the 8 version, there is the similar procedure. You should know about how does it works. You're basically saying where is the document, what is the page of this document used. Now we are saying what is the real materials. Okay. Of course, if you want, you can use a filter phrase. In this case, I'll just scroll through the list. Okay, and as you can imagine, the management of this Excel document is way easier than to try to manage items on the CAD system. And once it's done, if you say I want to see the changes, apply the appearance on the model, and that's basically it. You have this nice looking dark kitchen. If you don't like it, of course, you can just apply another scheme and you will get it. Okay, now let's speak about the assembly copier. It's a great tool which allows you to have a copies of your initial designs or some legacy data that you already have. And if you work with Inventor before, you know that Inventor mimics the real environment, real world, which means that you have separate files for the parts as well as separate files for the assembly. So if you have a set of files, maybe you can combine one assembly or the other one. So this tool allows you to have an independent set of the part files as well as the new assembly without losing any relations. Yeah, so you can just make a copy without losing anything. Set the new names for a copy of the components and just make a new design. So this tool was completely rebuilt from the ground for various reasons. Okay, so because here there was a need to include some embedded files like Microsoft Excel, documents, images, and so on. So now Assembly Copier allows you to do this. Okay, now what do we have here? There is a post-processor improvement. We have a new post-processor for the Mark 3 and 4 post-processors for enthusiasts who make their own routers controlled by this Artsoft product. So we have an output for them. For those of you who utilized the ERP CSV format tells a lot. In some of the cases we need to use comma-separated values. Now we have a new Western European encoding besides standard UTF-8. There might be a situation when you have 2 machines or maybe more machines on the factory, but they have some differences in their behavior. Yeah, so we have the same machine, identical machines of the same manufacturer, but there is something different in them. Basically, we can have a different configuration for the post-processor now. We don't need to make a copy of post-processor or do something workarounds. We can just say that I want to use configuration 1 for the machine 1, configuration 2 for the machine 2. As simple as that. Of course, beside the programming, there is some leading materials which also supplies with the Woodwork. We rebuilt our initial videos, which allows you to just go all the way through the design. If you're a newbie, those will be very useful. They allow you to feel how to build a model from scratch and go through all the stages of the design. And also we reworked the manual, which allows you to see new features and know how to use them. Okay, now let's see how much time we can save using a Woodwork for Inventor. There is like very rough estimation we got from our customers. So most of them saying that on the 3D modeling they spend about 40% of their designer time, and the rest 60% is spent for the data preparation for manufacturing. Of course, those proportions may vary, and depending on the complexity of the model, this modeling time shrinks in most of the cases. So the more and more time is needed for data preparation. As you understand, this is like a routine process with the place for human mistakes, and that's why we focused our efforts on shrinking the preparation time. And using Woodwork for Inventor, in our estimation, and as well as the reports of our clients, we can shrink those times to get as much as double the efficiency. Yeah, so we just significantly reduce the manual work with the model. Yeah, and you can get up to, maybe not up to, but starting from, let's say like that, because some of our customers says that they even triple their efficiency. Yeah? So they waste way less time on the data preparation. Okay, because of the higher automation degree, we reduce amount of mistakes about an 80%. So now let's see a few examples of our of the models which was made by Woodwork for Inventor and what we have here. So there is different kinds of furniture, as you can see. There is maybe office furniture, some open desks, some sales points, hotel receptions, and so on and so forth. So as you can see, there is virtually no limitation on what can be designed by Woodwork for Inventor. You can even design something like the furniture with metal parts, because we rely on Autodesk Inventor, which have very powerful tool for sheet metal processing. Yeah. So probably now we need to wrap up our conversation. So if you have some more questions and you need to get more info, we kindly ask you to send your questions to info@woodworkforinventor.com, because each of our customers have their own unique workflows, and if you have some questions about how it's better to solve one or the other problem, it would be better to just direct your questions to this email box you see on the screen, and we will contact you in order to provide the better answers. So at this, I'd like to thank you very much for your time. I hope this demo was interesting for you, for the new users as well for existing users. And as always, I'd like to ask you to follow our news in our social media channels, YouTube, forums, and so on. Thank you very much. See you.